It's time for video lesson number 20. Today's lesson is on measurement, meaning area, perimeter, surface area, and volume. You will need for this lesson, of course, your TOC number 20. You will also need a pen or pencil to take notes. You will definitely need a highlighter for this lesson because I want you highlighting the measurements on each shape. And you will be allowed to use calculators for this lesson. However, even though you're using calculators, you must show work. So looking at the top of page 20, we're going to review what these different terms mean. Perimeter, of course, it measures the distance around the outside of a figure. And the keywords you're looking for are around, surrounded, outside, enclosed. So some examples that you're going to see are putting a fence around a garden or around a backyard because the fence goes around the yard. So you're not talking about the inside of the yard, you're just talking about around. Putting cement around this pool would be another example of perimeter. And if you think of crime scenes, I know you guys are all into the crime scene shows, but when there's a crime scene, the police put that crime scene tape around the outside of the crime scene. With perimeter, it's important that you just remember there's no secret formula. You just add up all the measurements around the figure. So you don't have to worry about the formula sheet for this one. There are perimeter formulas you can use, but if you just think of, hey, I'm just adding up everything outside, you'll be good. So for area, this measures the square units inside of a figure, and I want you to think of keywords such as covers or covered or inside, and it's important that you notice that these are square units, meaning that every time you find an area problem, it's always squared. Your answer is going to be millimeters squared, or inches squared, or yards squared. And to help you remember this, think of the little saying area squarea. That will help you remember that every time you solve an area problem, you need that little tiny 2 to show, or an exponent of 2 to show that your answer is squared. Some examples of area in real life would be growing grass on your yard, if you need to know how much area to plant the grass in. Painting a wall or covering a wall in wallpaper. Both of those are covering the surface of the wall. And then if you think about, sometimes they'll talk about a sprinkler, sprinkling, and this is a picture of farm, but they'll have these big, huge irrigation things, and they're actually spraying the entire inside. So you got to think, is it covering the entire inside, or is it just covering that little bit outside? Another one would be carpet. If you're thinking about laying down carpet, that would be another example. And with area, make sure you're looking at the correct shape because there are different formulas for each shape, and this is important. Sometimes it's a rectangle, sometimes it's a square, sometimes it's a triangle. So with all of those, and then you'll have circle, and we'll get to that later. But make sure you're looking at the correct shape for the right formula. All right, one of our new measurement topics we're going to be talking about is something called surface area, and I know this is new for you. This is where you're measuring the square units on the outside of a 3D figure. I want you to draw a rectangle around the word, or the little notation 3D. That means it is a 3D shape, meaning a rectangular prism, which is a new word that you've never heard before. It's just basically a rectangle, but it's got three dimensions, length, width, and height. So again, since it's area, our keywords are covering, or covered, wraps, surrounds. It's anything that's on the outside of that figure. So because it is area, we are going to square our answer, or have square units on the end. So think of that term area, squarea. And here's some examples. Wrapping a box in wrapping paper. They like that example. So if you see wrapping paper, think surface area. If you're painting, this is a picture of a flower box or window box, it has flowers in it. And if they paint that window box is a rectangular prism. It has a length, a width, and a height. And if they're painting the outside, that would be surface area. And then on the last example, you guys are all into the origami shapes right now, but when you're taking a piece of paper and making a box, that is also considered surface area, because they would say how much paper is needed to make a rectangular prism. With surface area, this is so important. You must follow the order of operations with these problems. You will have both multiplication and addition in this formula, and it is so very, very important that you follow the order of operations to make sure you're not getting the incorrect response and showing your work. And the last one we're going to talk about is volume. Again, this is with a 3D figure, so go ahead and draw a rectangle around 3D. So that you remember that this is a 3D figure, meaning has 3 dimensions. And volume, since surface area was on the outside, volume is measured in cubic units, meaning it has a little tiny 3 for your exponent, and it measures the inside of a 3D figure. And you'll see things like how much is contained inside, or if you fill a box, or things like that. So think anytime you're putting something in and saying how much is fitting inside the box, then that would be volume. Anything that wraps on the outside would be surface area. And it's important that you know the difference between those two, because you're going to have word problems with these and you'll have to know which formula to use. And since this is volume, volume is cubed, which means it's labeled with an exponent of 3. So you'll have millimeters cubed with a little tiny exponent of 3, or you'll have yards cubed or inches cubed, meaning because you're taking an inch times an inch times an inch. So that's why it's cubed. And a quick way to remember it is V and 3 rhyme. So V3, V3, volume 3. So here's some examples of volume. Is how many packing peanuts would fit inside of a box, how much candy fits inside of a box, and how much dirt would you put inside of a flower box to plant some flowers. And once with surface area and volume, it's important that once you choose the attribute, because you have length, width, and height, that you're going to identify, oh, this is the length, this is the width, and this is the height on the shape. Be consistent. Make sure you label it on the shape so you don't get confused and leave out a measurement, especially when you're looking at surface area. So how to solve measurement problems. These are really easy as long as you're writing down and following these steps. First step is you're going to write down the formula from the formula sheet. Again, with perimeter, you don't need one. You just add up all the outsides, but you do want to show work. Number 2, plug in the measurements. Be consistent. Label the parts on your shape first. So just plug in those measurements. And then number 3, solve using the order of operations, or PEMDAS. So watch out for Aunt Sally, because she's coming after you if you don't use those order of operations correctly. And this is especially important with your surface area problems, because with surface area, you've got addition and multiplication all in the same problem. So you don't want to do them out of order and then get the wrong answer. So let's look at some examples. And I know you've had area and perimeter in the past, but I'm going to show you how they're going to get a little bit more complex. So if you look at this example, this is what we call a complex figure. And there isn't a formula on your formula sheet, because this is like taking 2 shapes and putting them together. So where these get a little bit harder is, you see you've got 6, 7, 8, 24, but you're missing that left side. And so you have to kind of be a detective and say, okay, well, how long would that be? And if you look on the right, you had 7 centimeters going down and then 8 centimeters going down. And if I add those 2 together, I would get 15 centimeters. So I know that that side has to be 15 centimeters based on the other measurements that are given. Now that I have that, I can just add up all the sides So let's start 6 plus 7 plus 8 plus 24 plus 15. I literally just went around the shape and wrote them down. Then grab your calculator, add them up, and you get 60 centimeters. Don't forget to label your problem. This is going to be really important because on the SOL, they will give you centimeters squared or centimeters cubed or just centimeters, and you have to know which one is the correct answer because they're making sure you understand the labels too. All right, so let's look at an area problem. We just looked at perimeter, so this is area. So on this one, in order to find the area, first thing we have to do is we have to find the area of each shape because we have two separate shapes here. So we're going to subdivide it, meaning we're going to cut part of the shape off so we have two distinct shapes so that we can find the area of each. So the first shape would be a rectangle because it's 6 and 7, it's not a square. So I would take the rectangle formula, which is length times width, take 6 times 7, plug in those values, and 6 times 7 equals 42. This is area, so it's area square area. Put that little tiny 2 exponent. And then the next one, the two measurements are 8 and 24. So we write length times width, plug in 8 and 24, multiply those on my calculator, and I get 192, meaning that the area of that larger shape is 192. At the end, I just simply take the 42 and that 192 and add them together, and I get a total area of 234. You may or may not see complex shapes on your SOL, but I just wanted to expose you to it so that you know what to do when you're faced with those. It's just like dividing them up and taking them and adding the areas at the end. So they're not as hard as you think. Here's a triangle one. I know you guys did these in 5th grade. A lot of times students get confused because they ask for perimeter of a triangle and they're like, what? I don't know. There's no formula. Well, you're just adding up all the sides. So take them up and add them all together. 8 plus 15 plus 21. And that gives you 44. It's not that hard. Perimeter is the distance around. Just add up all the sides. And then area, if you look at your formula sheet, and I put a little snapshot, it is going to be in the inside front cover of your workbook. So you'll always have a copy of it. But if you look at this one, here's your triangle, and your area formula is represented by the big A. It says 1/2 base times height, where base is the bottom of the triangle and height is the height of your triangle, or how tall it is. Keep in mind, when you go to the doctor and they measure your height, you're never standing at a slant, so you're always standing straight up and down. So when you're looking for the height of a triangle, look for the line that's straight up and down. So in this, we're going to write our formula. A equals 1/2 base times height. Here's our measurements, 8 being our base and 15 being our height. Plug those in. And for this, I turned 1/2 into 0.5 so I can put in my calculator. Another way you can do it is just to multiply 8 times 15 and divide by 2 at the end. Either way, you'll get the correct answer, but those are two different ways you can do it. Once you plug in those numbers, you can just multiply straight through in your calculator, and you end up with 60 meters squared. Again, this is area, so it's area square area. Make sure you put that little tiny 2. Here is a square example. Now, what do you do when they only give you one measurement and you have to know the perimeter of all 4 sides? There is a perimeter formula, but since this is a square, we just study quadrilaterals. On a quadrilateral, or a square, all 4 sides are the same. So add up all the sides, I get 32 plus 32 plus 32 plus 32. The perimeter formula on the formula sheet says 4 times 32. Either way, you're getting the same answer of 128 millimeters. And then for the area, if we look at our formula, we have S to the 2nd power, or S squared, because it's the side squared, which is the same formula, technically, as the rectangle, which is length times width. But in a square, all the sides are the same length, so it's just side times side, which is the same thing. So write your formula. Plug in your 32 as your side length. 32 squared, remember this is the same as 32 times 32. And if I plug that in my calculator, I get 1024. And it's area, so it is millimeters squared. Last two examples, and we will be done. These are the new ones you guys have not seen before. This is a 3D shape, meaning it has the 3 dimensions. It's called a rectangular prism. So you will see that word prism, and that should tell you it's a 3D shape. For volume, if you look, this is the only 3D shape on your formula sheet. You're going to use volume equals length times width times height. And notice they don't label your length, your width, and your height on your shape. So my suggestion is that you highlight each measurement and then pick which ones you want to be length, width, and height. Typically, length is the one that's the longest, width is the one that goes from front to back, and height goes from bottom to top. So then once I have those, I plug them in. Volume equals 12 times 5 times 6. Pretty easy. Take your calculator, plug those into your calculator, and you get 360 inches cubed. It's important that you know this is volume, and since I multiplied inches times inches times inches, I end up with inches cubed for my answer. Last example, and we're done. Find the surface area of the figure below. And this is, and we'll show you this example in class once we get here. You're finding the area of each face of the prism, meaning the front, the back, the sides, and the top and the bottom, and then you're adding them together. So your formula is here, twice the length and the width, meaning the front and the back. That's the area of each face, and then there's 2 of them because you have a front and a back. And then you're adding the length times the height, which is your sides, and then your width and your height. So once you write down that formula, again, go through and highlight all of your parts, determine which one's length, which one's width, and which one's height. And this is very important with surface area because you don't want to use the same measurement more than twice. So make sure you label it so you know what you're plugging in. Then once you do that, you can plug it in. And this is a lot of writing, I know. It'll take 5 seconds of your life, and if you write it down, you're less likely to make a mistake. So once you do this, this is where the order of operations comes in. You have to do all your multiplications first. So take your first section, 2 times 12 times 5, then multiply your next section, 2 times 12 times 6, write it down, and then 2 times 5 times 6. So when I do that, I end up with all of these numbers, and at the end you add them together for 324 inches squared. This is back to area, so you use a exponent of 2. And that is it for our video. It's time to log in and show what you know on your homework quiz.